Thanks a lot, Torsten, Daniel, Dave, and Joseph. So now, as we heard about vision, automated part handling, and software, let's move on to see how all of this is implemented in a production environment. So it's my pleasure to introduce our first guest speaker, Herbert Biller from Siemens. Herbert is a production engineer and expert in laser marking, digitalization, and Industry 4.0 applications. Without further delay, welcome, Herbert.
So, thank you, Alexander, for your short introduction. Well, I'm working in the Siemens Electronic Works in Amberg, the so-called EWA. In Siemens, sometimes known as one of the digital lighthouse factories. Well, what are we producing? Our products are programmable logical controller, so-called PLCs, especially the products of Simatic S7. Maybe you know the S7 1500 products. Additionally, some distributed I/O systems, especially ET200, Simatic ET200, with different families. And additionally, so-called HMI products. So this is the interface between the user and the machine itself, the PLC control itself, excuse me. So some facts about the EWA. We have around about 60,000 different customers. We are producing one product per second. And what we are driving for many, many years is this highest quality standard. Current value, we have this time 99.999% process quality. So, and what I think what's very remarkable for the EWA is the so-called horizontal and vertical data integration. And that's what I want to speak about in the next slides regarding our actual topic, the laser marking process. Yes, laser marking in EWA. What are we marking? We mark our devices and especially the product and technical information which the user needs to use our devices. And what's very important is a serial number. This is a unique number which makes each device a unique device. And this is also the very important link to our digital factory. Some facts about the laser marking in EWA. We have 50 fully automated printing systems which are integrated in assembly lines. And this is also one important step as part of the digital twin. And we have to create around about 2,000 new marking programs per year. So, and therefore, we had different projects together with our partner Coherent. And two of these projects I want to tell you about. One is the automatic laser program generation. And the second one is a relatively new proof of concept regarding the predictive maintenance. Yeah, automatic laser program generation is one of the typical samples for the vertical and horizontal data integration in our digital twin of the production. Here you can see three parts of the digital twin. One is the so-called digital twin product. This is mainly this area, this place where the development creates its data. The next one is the section of the digital twin production. This means this is the layer of the production planning. And the third one, the digital twin performance, is then the production itself. Yeah, the development creates its data in a PLM software. In our case, it's Teamcenter and NX. And there we do not have only EBOMs and drawings, but additionally also the laser marking data itself. So, and this data we transfer via an interface to a product data management system. And based on this data in the product data management system, we are able to create our marking programs full automatically. Therefore, we developed and realized together with Coherent an data generator, and this allows us full automatically create the laser marking programs, which then are transferred via interface directly on the laser machines. So this is a very typical sample for a vertical integration, data integration of a process in our digital twin. Additionally, you can see this laser marking process is connected to our MES system. And this is part of this horizontal data integration because the laser gets data from the MES system, in our case, the serial number, which afterwards is printed on the device. And the laser itself gives back some tracing informations to the MES system. So especially the serial number afterwards is the base for all tracing data of the following process steps. There we read this code, which is written on the device, and we can follow step by step all following processes for the production. Yes, you can see vertical and horizontal integration of the laser system in our digital twin. Yeah, the next what I'd like to show you is some information about predictive maintenance. So I think many of you know these goals of predictive maintenance, increasing equipment efficiency by avoiding of unplanned downtimes, reducing maintenance costs, and this dashboarding, viewing, and analyzing of machine data. What are we doing? We are collecting all data of the sensors which are already part of the laser on the laser PC. This data afterwards are transferred via two new interfaces to an edge device. In this edge device, we make a pre-sorting, pre-analyzing, and the results then are transferred to the Siemens MindSphere cloud. And there you have different abilities to analyze this data via different mathematics algorithms and different other methods to get any indicators for an upcoming maintenance. So in our case, currently we are collecting this data, and the plan is to view this data in the next months, to analyze this data and to find some indicators for an upcoming maintenance. The big advantage of this system is also that not only Siemens is able to view and analyze this data, but also our partners, in this case, Coherent. So Coherent is able to see actually online the data of the machines. They can analyze them. They can help us with problems. Yes, you see, in many years of cooperation together with our partner, we are continuously contributing and optimizing this integration of the systems in our way of digital twin. Yes, this was very short, a short introduction about that, what we are doing. I say thank you for your attention and hand back. Thank you.
Reducing equipment cost without sacrificing performance is a challenge that many laser marking system builders must face in order to compete, especially with non-laser technologies. Next, we will hear from Schou Christensen from SVM, a Stevanato Group company that builds automation equipment. His customer gave him such a challenge: significantly reduce capital cost and operational cost without sacrificing throughput or marking quality. This is a great example, as it shows that with the right partner, you can implement innovative laser marking solutions. And it can help new customers overcome objections and enable them to implement laser marking technologies in their operations. So, over to you, Jens.
I welcome you for today's presentation of the 3D mirror chamber laser marking system that gave us new opportunities by being able to reduce CAPEX and OPEX costs significantly for our customers. My name is Jens, and I represent the organization called SVM Automatik in Denmark, being a part of Stevanato Group, that's a global vendor or supplier for the pharmaceutical industry. We've implemented a lot of laser marking systems, laser welding systems over the years, more than 250 laser marking systems, marking products like this, where you see marking on the side and on the top. We also have metal products like this, but also the pharmaceutical products like injection pens like this, where you have both the label to be marked, but also the scale drum to mark here in order for the patient to set an accurate dose and inject the drug, could be insulin. So we made a lot of these installations over the years, starting out more than 20 years ago with the first generation, where you see the scale drum to be marked. And you see the setup with 4 laser systems marking each their 4th part of the scale drum in a fixed position. So that gives some sensitivity in the angles that I've marked here with red, due to the fact that you'll have some item variation, you have some positioning variation, mandrel by mandrel, and so on and so on. And also with the bulk in feed for the inline integration with the molding machine, you have some variance. So some of these challenges that we saw with the first generation were, of course, implemented as optimizations for the second generation that we made approximately 10 years ago. Mainly due to the laser marking time, it was decided to go with 6 lasers instead of 4 lasers. And that, of course, reduces the sensitivity by the angle is being reduced. Of course, you need to utilize the cylinder compensation feature of the laser marking software when marking on these circular surfaces here. But as you see, a positioning tolerance of 30 microns of a millimeter and a rather high CPK value is needed for these products here. Please note the laser utilization rate of approximately 70%. It is by having one item being presented to the lasers, then you do the laser marking process, and then you transport the items representing the next item to the laser marking. Then you will have approximately 300 milliseconds of transport, and then in between 600 and 800 milliseconds of laser marking. That gives you a utilization rate of the laser marking system of approximately 70%. The laser utilization rate tells you something about the OPEX costs of having a laser system. We also implemented an inline vision system measuring all the lines, the position of all the lines and numbers by having this unfolded image or picture of the complete surface. Bringing back or communicating back the optimization parameters for the laser system. So the system is optimizing itself when you start the system. it will start optimizing all the positions of each single mandrel and each single laser segment on that mandrel. So a lot of parameters being communicated from the vision system to the laser marking system, and so on and so on. So all of that, those experiences were actually used to find the solution for the challenge that we received, in close cooperation with our very good partner Messenger in Denmark, offering the coherent laser marking system for us. So this is actually based on a reinvention that we made in 2000, or an invention that we made in 2008. So the customer said the scale drum is very often the most costly component in our injection pen. So please reduce the capex and the opex significantly for us. And furthermore, please double the capacity, because we found optimizations in the molding process. We are willing to reduce the CPK, the required CPK, for 1.15, but we also would like to re-implement the bulk in feed. And by the way, we prefer marking on the fly, but it's just a preference. And we had to do some tests together with Messenger and Odense, and we ended out suggesting this reinvention of the mirror chamber. And as you see here, you have one laser marking system being mounted on the top, and then you have this chamber with mirrors, and then you have a number of scale drums being presented underneath. What you see here is what we made in 2008, and that is actually for with a system where you're able to mark both on the top and all the way around this on the sides of this round product with this mirror chamber. So 7 sets of primary and secondary mirrors are implemented in the mirror chamber, completely covered or dust covered, closed in the bottom. So you don't have any dust issues with this mirror chamber. But we use this in combination with all the other experience that we had to invent this system where we are replacing those 6 laser marking systems with or at least the 5 of those 6 laser marking systems, we replace that with one mirror chamber. So the animation that you'll see now shows how we eliminate first 5 laser systems, implement 2 simple mirrors with a very, very high reflection rate for the wavelength that are being used. Then we move the laser system on top, and then we implement, instead of the 5 lasers that we eliminated just before, we implement 5 extra sets of mirrors. And now you're once again able to mark with the same system, basically, all 6 segments of the scale drum with one laser system. And in order to reduce the marking time, the laser power were increased from, I think, 40 watt to 100 watt. But that is where I'm not that much of an expert on the laser marking process itself. We're just the machine vendor implementing these laser systems. So you see here the animation, eliminating 5 lasers, implementing 2 mirrors, moving the laser and the mirrors, implementing 5 extra sets of mirrors instead of the 5 laser systems. And now we start marking mirror by mirror to the scale drum, segment by segment, and then we put a housing to that. That is what I call advanced simplicity. So some of the calculations behind this system is done in order to find the right setup, to find the right balance of how many items should we present to the laser marking system. We had the possibility to present up to 7 items inside this mirror chamber without them being a shadow to each other. So we ended out in the suggestion of having 6 items being presented to the laser system, 2 sets of laser and mirror chambers, giving us the possibility to offer more than 110 parts per minute with only 2 laser systems. But please note the laser utilization rate of 95%. So, as I'm explained, the laser system is 100% of the time that it is being turned on. So before we had 70%, 60% of laser utilization rate. Now we have 95. So it's a dramatic reduction of the OPEX. But the major reduction is by implementing the increased laser power and the reduced marking time. So you'll have many more items from less laser marking systems. In order to test this, we made a mock-up, and as you see in the lower left corner, we have the mock-up with one dimension, so only one side, and the video that you see in the middle is just showing how all 6 sides of the scale drum are being marked with by these mirrors. But of course, in the final application, you'll have 6 sets of mirrors, and then you do not need the rotation that you see being done here. You see in the right side that the quality of the marking is pretty much the same as we do today, with 6 lasers at 54 parts per minute. We can do that with 2 lasers and 110 parts per minute. So we actually were able to reduce the capex by 50%. So we doubled the capacity at the same machine price. The OPEX is dramatically reduced by more than 85%. But of course, it's just a guess. But you actually are having the same output with 2 laser systems compared to 12 laser systems. And then furthermore, you do not have any rotating parts in the machine. So it's a very, very significant reduction of both capex and OPEX. And that could be the argument needed when you are trying to convince new customers to go for laser marking instead of other print technologies for their product. Let me know if you have any questions or comments. I would love to have your input and your response on this technical solution. So let me know. And thank you for watching this presentation.